In non-standard analysis, the standard part function is a function from the limited hyperreal numbers to the real numbers. Briefly, the standard part function rounds off a finite hyperreal to the nearest real. It associates to every such hyperreal the unique real infinitely close to it, i.e., is infinitesimal. As such, it is a mathematical implementation of the historical concept of adequality introduced by Pierre de Fermat, as well as Leibniz's transcendental law of homogeneity. The standard part function was first defined by Abraham Robinson, who used the notation for the standard part of a hyperreal. This concept plays a key role in defining the concepts of the calculus, such as continuity, the derivative, and the integral. In non-standard analysis, the latter theory is a rigorous formalization of calculations with infinitesimals. The standard part of X is sometimes referred to as its shadow. Definition. Non-standard analysis deals primarily with the pair, where the hyperreals are an ordered field extension of the rails, and contain infinitesimals. In addition to the rails, in the hyperreal line every real number has a collection of numbers of hyperreals infinitely close to it. The standard part function associates to a finite hyperreal x, the unique standard real number x0 which is infinitely close to it. The relationship is expressed symbolically by writing the standard part of any infinitesimal as 0. Thus, if n is an infinite hypernatural, then 1, n is infinitesimal, and saint equals 0. If the hyperreal is represented by a Cauchy sequence in the ultra-power construction, then more generally, each finite defines a Dedekind cut on this subset and the corresponding real number is the standard part of U, not internal. The standard part function, saint, is not defined by an internal set. There are several ways of explaining this. Perhaps the simplest is that its domain L, which is the collection of limited hyperreals, is not an internal set. Namely, since L is bounded, L would have to have a least upper bound if L were internal, but L doesn't have a least upper bound. Alternatively, the range of saint is which is not internal. In fact, every internal set in which is a subset of is necessarily finite. See applications. All the traditional notions of calculus are expressed in terms of the standard part function, as follows. Derivative. The standard part function is used to define the derivative of a function f. If f is a real function, and h is infinitesimal, and if f exists, then alternatively, if one takes an infinitesimal increment, and computes the corresponding one forms the ratio. The derivative is then defined as the standard part of the ratio. Integral. Given a function on, one defines the integral as the standard part of an infinite Riemann sum when the value of is taken to be infinitesimal, exploiting a hyperfinite partition of the interval a, b. Limit. Given a sequence, its limit is defined by where is an infinite index. Here the limit is said to exist if the standard part is the same regardless of the infinite index chosen. Continuity. A real function is continuous at a real point if and only if the composition is constant on the halo of. See microcontinuity for more details.